Hey guys, welcome back to the shop today. I was talking to a friend, Mike J, who's on YouTube, and we had a conversation about his AK47 that he got, and he was talking about getting a muzzle device that not only breaks but hides flash. And I said to him, well, usually when you have some sort of flash hider, it will hide flash great, but it won't have much of a break, and when you have some sort of a break, it won't hide any flash really. They're kind of two parallel lines. But I said to him, what would you rather have, more of a break or more of a flash hider? And he said, well, I'd rather have more of a break. I just would like it if it didn't deafen the people to my left or right when I'm shooting at the range. So I started thinking about it, and I drew up a little quick sketch, and basically it's just a copy of an AMD 65 style break, just a lot shorter, just to lower the weight on the amount of the, or to lower the weight and the mass on the front of the firearm so you can transition from target to target a little faster, less weight, a little quicker for them. But I was thinking that we would cut a few holes at 12 o'clock to mitigate muzzle rise or flip, whatever you want to call it. And I was thinking, I thought back to the Browning bar hunting rifle. And on those, if you get the higher grade model, you can get what's called the boss, and the boss is adjustable. And if you look at the boss on the end of it, it's basically a tunable muzzle brake that you can screw out or in depending on the rounds, and it actually works really well. But when you take a really close look at the ports, there's ports 360 degrees around that Browning bar boss muzzle brake, and if you look at them, they're actually angled a little more forward. Like they're, for the most part, they're almost 90 degrees, but they're just angled a little bit up. So I was thinking, if I was going to do this, I would want to make some ports for them on the sides to reduce the felt recoil, but we'd probably make them just angled a little bit forward, thereby the concussion and the blast going more forward at a more forward angle. And I was looking at this and I was thinking maybe 75 degrees would give us like the best braking ability, and then also kind of getting more of that noise and concussion forward rather than to the sides where the people next to you are shooting, because they're not going to be in front of your muzzle at a shooting range. So now arguably you could make that angle more and more extreme, but the more extreme you get, just like the linear brakes that are straightforward, you really don't have any braking ability. It's just kind of a flash and noise projector forward. So I have some 4140 and I have some 1018, and I think I'm going to try to do it out of 4140 first, because that'll be a steel that's more like the steel that's on his barrel. I don't know if he got 4150 or 4140, but the 4140 would be closer to the steel than the 1018, so I'll try to do it out of the harder stuff, and we'll see what we can do. My idea is to get the angle cut, because obviously I'm only doing this on my own, so it's kind of on a budget. And in the real world, what would be best, what I feel would be a rotary table, a tilting rotary table with a 3-jaw chuck in it. So once you made up your blank, you could throw it in there, raise your table, so you could make like a 75-degree cut from obviously the center line of the bore. So what I have here is a little collet with an ER40 1-inch collet and a collet chuck, and we'd tighten that in there. And what we're going to use, or try to use, is a little angle block. Put that in a vise, and when if you see that, hold on here 1 second. Let's get this going in the right direction so it makes some sense to you. Once that's in the vise on the mill, that'll be straight up. So when the cutter comes down, it'll give us that 75-degree angle. So the issues that I see happening with this setup is when the vise is clamped in on this ER40 collet adapter and you're cutting down, there's going to be a lot of vibration, and that's probably, about 1.5 inches, 2 inches away from where you're actually clamping it. So this might want to walk out or vibrate or make a bad cut. So not the best way of doing this, but we are doing it on a budget, on the cheap. So we'll give that a try. This is for an AK47, so we're going to be cutting 14 by 1.0 left-handed threads, and I did do a little video on taps, buy once, cry once. So we're going to be trying that tap out. So without any further ado, let's go to the lathe. Hey guys, we just got that piece of 4140 all trued up in the 4-jaw chuck. There is just a little bit of difference here, about a half a thou. Let me rotate it here and hold the camera steady. So you can see that little bit right there. About a half a thou out of round. That's okay because we are going to be taking a skim cut for our outer diameter. Then we're going to punch a hole here so we can use a tap of 14 by 1.0 left hand thread tap. The general loose and fast rule, and no, this doesn't apply to all threads, but we are using a 14 by 1.0 tap, so we're going to drill a 13 millimeter hole. I don't have a metric drill bit here, so I'll be using a 33 by 64, which is really close to 13 millimeters, only a couple thou off. Anyhow, once we come out to our final diameter, I will be putting a bit of an angle at the base of this break to the tune of about 10 degrees, going from the center bore line out. Measures about 10 degrees. And that'll look a little bit like a AMD 65 style break. I also am going to make it a little shorter. I think I'm only going to do about 2 inches of total overall length on the break, just so he doesn't have a 2.5 inch, 2 3/4 inch break hanging off of the end of his muzzle. A little less weight, a little easier to transition from target to target. Anyhow, so now we're going to take this to our final diameter, and then we'll start punching the hole and making some threads. Hey guys, I got to add a real quick addendum. I actually looked through all the bigger drill bits I have that are over 1/2 inch, and I actually do not own a 33 by 64 drill bit. So, got a plan though. I have a .505 reamer, followed by a .510 reamer, followed by a .516 reamer, and that'll get us to 33/64. 33/64 is actually .5156 of an inch. So, had to just throw it in there. Don't have that, so we'll be doing a 1/2 inch drill bit, and then we will move to the reamers when we have to do that. So that's how it's going to go. We're going full overboard on apparently just drilling a hole and putting some threads on it. Anyhow, back to the lathe. Hey guys, and this is what I want to show you about those spiral flutes on this tap. Why they're so nice is because as you're drilling into a blind hole, it actually curls the chip and brings it out of the hole so you don't bunch up with a bunch of chips in the back here. You can just continue to cut down to the blind hole. Anyhow, just want to throw that in there. Okay everyone, so I just threw a real quick chamfer on the edge right here that'll aid in threading on the muzzle device. And now we will cut a 10-degree angle on here and here. Okay, let's cut that angle. Okay guys, so our next order of operation is going to be punching in our through hole in the front of the muzzle brake. Obviously, the tighter diameter hole on the end of the muzzle brake or baffles that you have, the more effective the brake will be, because expanding gas won't be able to make it around the projectile and exiting out. The 7.62 by 39 projectile does have a variance on projectile diameter. On the low side, 0.310 of an inch, on the high side, 0.312 of an inch, and I'm sure there's always exceptions to that rule, maybe higher or lower. But generally 0.311 is probably a good bet. Now, as I'm sure most of you know, not all rifle barrels are concentric to the outside diameter of what they are threaded on the end of the barrel. So, Now I have to take that into consideration and obviously go a lot more in diameter than the projectile is. Also, if you are, let's say, making a brake or some sort of muzzle device and the tap happens to go in, now this is an extreme case, but sideways like this, not to this degree, just a lot smaller, remember that that device will also be canted off and you might have a strike on the shallow side. So I think I might go to 0.360, 365, maybe somewhere in there, thereby giving him a nice tighter inside diameter hole and hopefully avoiding any kind of strike that he might incur while using his rifle. Alright, so did some thinking. We're probably just going to go 0.375, use a 3/8 drill bit, punch this hole all the way through, and then we'll be able to part it. Okay, so now we have our through hole. Now in the perfect world I would have punched that hole before even threading this, but that's how I did it. Hey guys, so our parting procedure went well. I was pretty happy with it. This is the surface finish we are left with. This will focus. So what we'll do now to make that better is we will wrap this with masking tape, put it back in the forge-out chuck, and then we will face the front of the brake. After which we will put this in the ER40 collet and we will start milling out ports for the sides of the brake and one or two at the 12 o'clock position. Alright, so we got the front done, looking good. We got the rest of it done, looking good. Now, it's time to put it in the ER40 collar, and this is going to have a cringe factor of, oh, I give it a 7. So let's see what happens on the mill. Okay guys, I had this on the mill ready to start cutting some ports into it, and I noticed how heavy it was. If you look inside here, I actually got to do some relieving in here just to make it lighter, if anything, because this thing is really heavy still. So back to the lathe, get some masking tape, tape around there, and then I'm going to plunge a boring tool in here and get some of this steel out of here, just at least lighten it up a bit, because this is still pretty heavy. So I'll see you back on the lathe. Okay, just got off the lathe, now we have a nice relief in there. Can't really see, let's see, we need to flash it in there. Yeah, maybe you can see it. So it'll focus. Focus, there we go. So we got a nice relief in there, now we can go to the mill. Alright guys, got this in the mill. Let's see how bad of an idea this is going to be. Stay tuned. Okay, there's our first hole. That's what it looks like. Not too bad. Let's see if we can do that a few more times. Okay guys, that's what the second hole looked like. Not too bad. Now I'll probably do that about probably 30 degrees on either side of that. All facing up and out at about 75 degrees. And you know, it's going to be pretty boring, so I'll just show you when I'm done. Okay guys, so I just got off the mill. Got all the ports milled out. And I gotta be honest with you, that went pretty well considering that I was kind of cringed out about how this would actually end up going. So now the last thing we need to do... Oh, this really won't even focus for this, will it? Too shiny. Oh, that's what happens when you have a shiny part. So all I have to do now... Oh, there we go. Now focused. So all we have to do now is drill the relief for the detent, obviously at the 12 o'clock position, just like this. And then we will be ready to, I'll probably deburr the edges here real quick, and then maybe put a final shine on it and drill the relief for that detent, and that'll probably be it. Okay guys, let's see if we can just punch this little detent through. Just double checking on the depth really quick. Let's just go a hair more. There we go. Okay, off the mill. Now we have our detent relief cut. Let's see how this does. This more in frame for you. See if we can get this a little bit better here, so you can actually see what's going on. There we go. Super tight lockup, actually. That actually worked out really nice. Anyhow, and all AKs are just a little bit different with their detent and lockup, but this one feels pretty good. So next we've got to blue this part. Now we got our brake, got some bluing solution in here. Around. This is after heating it up and obviously degreasing it thoroughly. One of the main parts about all this is having a really good technique for degreasing it. Because if you don't degrease it, it'll really look splotchy. Look pretty horrible. You won't be happy with your parts at all. I'm not saying that won't happen with this particular one, but usually if you get all the oils and greases and waxes off, you usually end up with something that looks pretty good. Okay, so we got the bluing on there, and the way we did it is we shined all the metal and then we hit it with some triple aught steel wool, or quadra-ox steel wool. Now we got this war-torn looking brake. Really kind of neat. Come on, focus camera. Kind of neat what you can do with all this stuff when you toy around with it a little bit. I think that's my favorite area right in here. Anyhow, that's how it's done. And now Mike can grab this and throw it on his rifle, take it to the range, and see how it works. So anyhow, like I always say, loose is fast, brakes only slow you down, and shotguns have a wider spread. You guys be safe and have fun at the range. We'll see you next time in the shop.